is a salt with a chemical formula of nitrate of sodium and carbon monoxide, which has been known since ancient times, and therefore has received several names which are still recognized today. These names are barbel, sulfate soda, natron, ash soda, and soda ash. Their uses are, among other things, is the manufacture of soap, glass, and dyes.
Okay, I'm going to talk about the classification according to the type of bonds. Here exist four types of bonds: the ionic bond, the covalent bond, the polar bond, and the hydrogen bond. The ionic bond involves a transfer of an electron, so one atom gains an electron while one atom loses an electron. One of the resulting ions carries a negative charge, that is called anion, and the other ion carries a positive charge, that is called cation, because opposite charge attract the atoms bound together to form a molecule. The second type is the covalent bond. This is the most common bond in organic molecules. A covalent bond involves the sharing of electrons between two atoms. The pair of shared electrons forms a new orbit that extends around the nucleus of both atoms, producing a molecule. There are two secondary types of covalent bonds that are relevant to biology: polar bonds and hydrogen bonds. And then to the third type is the polar bond. Is two atoms connected by a covalent bond may exert different attractions for the electron in the bond, producing an unevenly distributed charge. The result is known as a polar bond, an intermediate case between ionic and covalent bonding, with one end of the molecule slightly negatively charged and the other end slightly positively charged. These slight imbalances in charge distribution are indicated in the future by lowercase delta symbols with a charge superscript, plus or negative. And to the fourth type is the hydrogen bond. They are polarized to adjacent of H2O, that is, the water molecules can form a linkage known as a hydrogen bond, where the electronegative hydrogen atom of one H2O molecule is electrostically attracted to the electropositive oxygen atom of an adjacent water molecule. Consequently, molecules of water join together transiently in oxygen-bonded lattice. Hydrogen bonds have only about 1 per 20 the strength of a covalent bond. Yet even this force is sufficient to affect the structure of water, producing many of its unique properties, such as high surface tension, specific heat, and heat of vaporization. And I think this is everything about the classification according to the type of bond.
Now I'm going to explain how this compound is obtained. Pure sodium has a valence of 3s1 configuration. The electron from the 3s1 orbital is easily detached by other elements of nature, such as sulfur, oxygen, chlorine, fluorine, etc., forming mineral compounds where the sodium ion participates. Sodium carbonate. Sodium is accompanied by other ionic species in the solids. Of this, sodium carbonate is only one more present in nature. Since then, it has had use in all civilization through time. The formula. The chemical formula of sodium carbonate is sodium 2 carbon monoxide 3. How is it interpreted? It means that in the crystalline solid, for every carbon monoxide 3 to the -2 ion, there are 2 sodium ion. Structure. Sodium carbonate. In the image, the structure of hydrous Sodium, also called calcium soda, is represented. The purple spheres correspond to sodium ions, while the black and red spheres correspond to monoxide, oxide, 32 ions. Carbonate ions have a flat trigonal structure, while the oxygens often have their vertices. The image gives a panorama seen from a higher plane. Sodium ions are surrounded by 6 oxygen atoms from carbon monoxide, 3 ions, that is, in anhydrous sodium meets an octahedral coordinate geometry. It is enclosed in the center of an octahedron.
Sodium carbonate is used as a raw material for saponification of fatty acids in the manufacture of detergents, industrial products, homemade detergents, dishwasher, and soaps. Sodium carbonate has many applications. Some of them are glass manufacture that decreases the melting temperature of the glass, water treatment as a softener, chemical industry in the manufacture of caustic soda and obtaining sulfates, and phosphates. In the textile industry, helps fix the dyes in the fibers. In the food additive, it is an acidity regulator, leaving agent and stabilizer, and manufacture of paper, semi-chemical props.
As an environmental impact, the sodium bicarbonate is recognized as safe for the ecosystem and all the animals, but the studies continue for watching its effects and see if it is still harmless in bigger amounts.
Our team's conclusion was that with this project and with this research, we got a better understanding on the names classification, process of formation, and environmental impact of the carbon dioxide, which was a compound we were very familiar with, but we didn't know it as deeply as we do now. This project was very interesting to make, and we hope you find it interesting too.